Trying to differentiate this equation over here can be tricky because it's not like one of the usual equations where we have y is equal to x squared, or for instance we have y is equal to e to the power of x. We know how to differentiate the exponential, but the e is actually just a number, 2.718 and so on to the power of x. So if we could find a way of changing that 2 to e, in other words, if we could find the relationship between e and the 2, then we might be able to work it out. From these two relationships, I'm going to be examining this one where I've got an e to the ln x. I could also write this as e to the ln b, which would be able to be equal to b. I could also write this as e to the ln a, and the answer will be a. So in the same way, I could say that this is e ln to the 2, and the answer will be 2. And this is my relationship that I have. So instead of using base 2 up here, I'm going to be using e to the ln 2. Having done that, I'm going to rewrite this again. And this time, I highlighted a different part of that equation in blue. And so I'm showing you now another one of the 3 rules of natural logs over here, where ln a to the n is equal to, we can now bring the n across to the front and write it as n ln a. And this is exactly what we're going to do with the blue part of this equation. And I'm rewriting the x here and ln 2. And at this stage, we've come to a stage where we can start differentiating dy over dx. And that is going to be the usual way we would cut this out and bring it down. And now we're going to differentiate the blue part. If I differentiate just the blue, all I get is ln 2. It's just a number. And using this law here, going backwards, I will rewrite this as dy dx equals e to the ln 2 to the x. And if I highlight this part over here, you'll notice that this again resembles e ln x is x. So we can use this to rewrite this as, well, hence you can see that if y is equal to 2x, dy dx is going to be equal to 2 to the x ln 2. And so we could extrapolate this by saying that if I have y is equal to b to the x, then my differential function will be b to the x multiplied by ln b, and so on, if b is greater than 0. It cannot be 0 and it cannot be negative. So any number now can be substituted here. Say we'll have 8 to the x, and we can say that dy over dx is equal to 8 to the x multiplied by ln 8. And if you found this useful, and you might like to subscribe so to get more of this type of information for Mathematical Methods 12.